I've seen many organizations today taking their nicely structured data from a document database, from a relational or graph database, turn it into text documents, chunk it up and chunk it into vector indexes. It's insane. If you have already well-structured data, why would you turn it into stupid text and turn it into vector embeddings, which are completely okay?
Tell us a little bit about Neo4j. It's a very interesting technology that really shows graph databases and what graph databases are.
So you connect information, right? So you connect people, events, processes, products. So you can do traditional use cases like supply chain, software analytics, cybersecurity, and other things. Unlike in relational or other databases that compute connections between information at query time, and in graph database, we persisted at insertion time. So we basically materialize these relationships as first-class citizens in the database. And then when it comes to querying, we just follow pointers in the data.
Interesting, actually, because it actually carries intent, doesn't it? The relationships show, if you care about a relationship between two nodes, that's an intent that is something that is important to the business. You care about the business. Hello and welcome to another episode of the AI Native Dev. And joining me today, a great old friend from many, many years. We were talking about 15 years or so. Exactly. Michael Hunger, head of developer advocacy at
Actually, I moved to product now. I'm VP of product innovation.
Wow.
So I'm doing all the cool new stuff, the shiny things. I can basically see how you integrate like all the modern developments, especially GenAI today, but also like cloud integrations and so on into the graph database. So
congratulations, that's awesome.
It's basically what I've been doing even in DevRel for a long time with Neo4j Labs and so on. But now like officially in the product org and driving a lot of these innovation topics.
Oh, that's great. That's great. Well, that goes to show we didn't meet today, right?
Exactly.
I'm still here at AI Focus here in Stockholm, and I bumped into Michael both in the corridor and also in the keynote. You've been at Neo4j for, like I say, 15 years or so as well. Tell us a little bit about Neo4j, because it's a very interesting kind of like technology that really shows graph databases and what graph databases are.
So graph databases, many people basically know relational databases where you have rows and columns and tables, but in a graph database you have nodes and relationships, or entities and relationships. Basically what you would draw on a whiteboard, right? So you have circles and arrows between them, and then you can put arbitrary information on the entities, but also on the relationship, which is actually quite important. And you connect information, right? So you connect people, events, processes, products, whatever, right? So you can do traditional use cases like supply chain, software analytics, cybersecurity, and other things. And what's actually especially interesting, that unlike in relational or other databases that compute connections between information at query time, and in graph database we persisted at insertion time. So we basically materialize these relationships as first-class citizens in the database. And then when it comes to querying, we just follow pointers in the data, which makes it much, much faster for these complex queries as such, right? So Neo4j has been around for a long time. It's been an open source database for a long time. It has Swedish roots as well. So it comes from Malmö, Sweden, actually. And now we've, of course, expanded globally, but I joined when we were 10 people, like 7 Swedes, a Brit, an American, and me. Basically.
Really? Sounds like the start of a joke, that, doesn't it?
And 7 Swedes, a Brit, American, 7 going to a bar.
They went into a bar and
they kick over some tables, right? So
and all of a sudden they form relationships and graph databases were born. There we go. So I expect no one laughed at that on the audience just then, but we laughed. So that's the important thing. So graph databases have been around a long time. People who care about the relationships between nodes, the relationships between data, which is very, very hard to essentially almost like you're forcing it in a relational database.
It's quite a pain. If you tried this ever, I mean, object relational database impedance mismatch, right? So that's like there's even a term for it. Whenever you try to take a rich domain model and shoehorn it into relation, it's always painful, right? So and basically in a graph, it's more natural. And it's also what's interesting, you don't lose the business people, because in a relation database, if I show a business person like 250 tables, they say, okay, what do you want to tell me? But if you show them basically the connected information on the screen, how all the things go together, then they say, oh, I see, and you missed this relationship here, by the way. So something like this. So you take also the people from the business side along, which makes it for much richer development experiences.
It's interesting. It's interesting, actually, because it actually carries intent, doesn't it? The relationships show, if you care about a relationship between two nodes, that's an intent that is something that is important to the business. You care about the business.
And because you can put attributes on the relationships as well, you can actually score this intent. You can even put weights and scores and things like that on that as well, or like time frames, right? So if you have certain relationships that only exist in a certain time frame, then you can basically put this information on it as well, which you then can use for recommendation, for fraud detection, and other things as well. Where the not just the attributes on the entities are important, but also how are they connected and when and how strongly are they also connected. Which then ties actually even further into graph algorithms and stuff like that. They go into page rank and clustering and like all the other things.
To see how close nodes are and things like that.
Or how important one node is in a network. For instance, if you have something like a fraudster and they have a really high centrality, that means they had a lot of influence in this. But if they have really lower scores, centrality scores, then they have not started their fraud business yet, so you can catch them before the fact, basically.
Cool.
So there's
and of course, graph databases have been around
for a while.
They're not new. They're not like
I mean, I still love it, and I'm still excited about it. But we've been around for a while, and people have been using Neo4j for a long time.
And just in their normal applications, where the relationships between data is important. Graph databases are a great way to implement that and then use that within your application. However, now AI has come along.
Everything is changing.
Everything changes. And now I mentioned you got two sessions. One was about how graph databases can help you, particularly in and around the RAG space, and actually pulling context in, whereby if you get some kind of a prompt, you can actually understand relationships between what you're hitting in your RAG database equivalent, and as a result, you can actually pull various bits of context that are actually adjacently important.
Exactly, the adjacency, right? And the surroundings are important, right? Not just the exact thing that you get back from your vector search or something like that, but actually what's surrounding it. How does it connect to the context of the user who's actually asking the question?
Right.
How does it connect to the business processes and other things, right? So you get much richer answer back from the database, which you then pass to the LLM for the final
Amazing.
answer as well, right?
So I'd love to talk about that, and then you go on later this afternoon to talk about MCP.
My other favorite, one of my other favorite topics,
and specifically about how devs and dev tools can be used with MCP to effectively make developers more productive. So I really want to focus on that as well. But let's talk about how you can use graph databases in a RAG. I guess to start off with, when we kind of use more traditional, kind of like not traditional. We're only a few years in, right? But non-graph database RAG, basic RAG. What I think most people know how kind of people use RAG today. What are the downfalls there? What are the pitfalls that actually say, do you know what, this isn't good enough? We need to be better here.
Yeah, actually, it's kind of interesting. So I was at AI engineering conference last week in San Francisco, and they actually put up an RAG assistant using vector search of their conference. And and I tried to find my talk, putting in my name. It didn't find anything. I was talking to a bunch of people from Microsoft about MCP, and they had a talk as well, and that basically show me all the talks from Microsoft on MCP, and it didn't show anything, right? So it didn't show me two other talks, but not the one that I was actually looking for. So what I want to say is basically vector search of content, where you only have fragments of content, has a bunch of downfalls. One is it's a black box, right? So you basically do vector search, but you don't know why and how you actually get these responses. The other thing is also it doesn't take context into account, right? So it doesn't take in account like MCP is actually a topic, and this topic is connected to other talks, right? So even if it didn't find the talk in the first vector search, it could actually via the context of MCP pull the other talks in, for instance, right? So and then from that perspective, that's something where if you only limit yourself to the text fragments, you're losing out on a lot of information that's actually in your data, right? So most people have actually more than documents. They have already structured data, they have semi-structured data, and lots of other data sources as well.
And what was interesting, actually, one of the examples you gave in the keynote was, I think it was about similar to like a company that has, maybe it was putting in it had an issue or something like that, and it was a ticket that was raised. Other things like, well, what other tickets have been raised on this same topic? What other tickets has the company raised? And you can all of a sudden, based on a request, start getting a huge amount of context, not just about the text string, but about the individual, the company, the relationship.
Exactly, the customer path.
The customer,
Look at the customer, for instance, from the input, you don't just look at the question string, but you also look at the customer who's asking it, and you actually look at what has the customer actually deployed and what is enabled and so on, and then you tie it back to the support case and say, okay, have you already asked previously similar support cases? Perhaps it's in subsequent follow-up error or something like that.
Maybe they've tried other fixes, and actually you won't go through those again.
So you understand the full story. It's basically like, you could almost say like a customer 360, where you see the full story unfolding, and then basically the customer support agent and the LLM can basically take this rich information and craft a much more personalized and more relevant answer for this. And the other thing that's really important is when you just get these text fragments back from a vector index, it's basically black box, right? So you get it back, but you can't explain why and how it came back.
Yes.
But in a graph, you can actually point to, oh, we fetched this information, and this is why we fetch it, because exactly these relationships exist, and because the score on these relationships is higher than X and so on. So you can also, if someone is interested in the kind of why, you can basically show them where did it come from, why was it retrieved, and so on. So basically also have this explainability, which in some industries is also important for auditing or for regulatory purposes, or just because I want to know, it didn't answer my question well, then I want to know what was actually missing. And it might actually be that in your source data one relationship was missing that usually connects some stuff, but in your data import it was didn't come in.
And this was interesting actually, because in your session you did kind of like show, if you was to look into normal RAG, you'd essentially just see a whole bunch of floating point kind of like numbers, negative numbers, vectors.
Can you make sense of them? I can't.
No. It's basically a binary file. It might as well be a binary file. Whereas from the RAG point of view, you'll actually see, what do you see? Do you actually see the nodes and the relationships and things like that?
Exactly. You can show them, if your application or your assistant or agent supports this, then you can basically say, oh, I want to drill down, or I want to see the details. You click on a link, and then shows you basically the visualization of what information was pulled in and how is it related. Basically.
So from an eval point of view, then, who would there be a person who would look at a general request and then say, right, okay, I know what context should be here, but it's not. How do I then actually make changes to the
So, for instance, when you had a live system and you get a user feedback, or you basically either active or indirect feedback, then you see, okay, these answers should actually be coming from the system. Why are they not coming from the system? And then you can basically drill down and say, basically, what is happening here? Why are the users not happy? Then you can actually see, oh, there was actually a whole part of the information that we have in the system that was actually missing because it was disconnected, or it was not found in the index, but if there was a relationship here, we could actually fetch it through this as well, right? And then if you set real eval pipelines up, then you would basically say, as part of my eval scoring, then you can compare for the lower scoring ones, kind of what's missing in the structure. And you can also have this interactive for the end user, where you basically say, okay, the end user can actually drill down and see what is actually behind this answer, right? So, and then you can go further and basically investigate more, for instance, or basically ask follow-up questions that follow the context information.
Yeah, interesting. How would you populate that then? Because like obviously with a regular pine cone or something, I just kind of like throw stuff at it and just think, okay, that'll hopefully do.
Exactly, there's a mix of stuff, right? So for once, many people already have structured data, right? And that's actually something that my toenails almost roll up. So I've seen many organizations today taking their nicely structured data from a document database, from a relational or graph database, turn it into text documents, chunk it up, and just chunk it into vector index, which is insane. If you have already well-structured data, why would you turn it into stupid text and turn it into vector embeddings, which are completely opaque? So one is the structured data that you already have, which might be your customers, your projects, your employees, your processes, whatever. And then also the unstructured data that you get from PDF documents, from research reports, from customer tickets, and so on. So you basically use the structured data and the unstructured data together. And for the unstructured data, actually LLMs are also super helpful. In the old days, we did a lot of NLP, Stanford NLTK, and like all the other stuff. But now actually LLMs are so good at extraction and language skills that you can provide them a schema and instructions and the text, and it will actually extract entities and relationships and attributes from
even from unstructured data.
Yeah, even from and that's actually pretty cool.
I was going to say, how accurate is that though? Will it try and create relationships?
As usual, it's not perfect, right? So you get perhaps to an 80%, sometimes 90% rate. But it's still better than having nothing or having a human go through gigabytes of data, do it manually.
Yeah.
And then you can also do multipass, and there's lots of ways of how to improve this as well.
I suppose a failure there would be it's adding context that isn't relevant. So it's actually not as big a problem.
Exactly. But that's something, because you have the schema already, you can just validate against the existing schema and drop the stuff that you're not interested in.
Yeah.
So from that perspective, you also have means to improve it. And then there's like things like entity resolution and other things. There's also graph algorithms that you can run then at the end on top of stuff and say, okay, these 5 assignments are actually the same assignments, so we merge it together into one. And things like that.
Interesting. Let's switch gears a little bit. Let's talk about MCP, the hot topic, right? Go. MCP. So interestingly, so first of all, why did you pick MCP from a dev point of view, as in a dev tooling point of view, versus an app point of view? It's
a really interesting one, because I was so I started out with MCP actually early December. So Anthropic published their blog post and the framework or the spec in late November, like last week of November. And I built the first MCP server for Neo4j in early December, like first or second week of December. And so initially it was like data, right? So just looking at data. But then I thought about, actually, this data also has metadata, it also has the schema. So as a dev, I can use the schema to, for instance, generate GraphQL type definitions or Java classes or Python pydantic classes. And then it got me thinking, okay, if I have this, and I can use MCP to wrap it around APIs, could I also wrap basically infrastructure APIs with an MCP server, right? And then I saw that some other folks like Cloudflare and others have done this as well. So you can spin up Cloudflare workers with MCP. And so I basically built another MCP server that wraps the Neo4j cloud APIs, basically, where you can provision databases and scale up and scale down databases and stuff like that behind the MCP server. And then it turned out it's actually really nice if you're in your IDE and just say, hi, I'm in Cursor, give me my instances, scale up this instance to something. Oh, I need a quick test instance. And basically, as part of your chat, behind the scenes, it can go off and do stuff. And then you saw more and more of these kind of dev MCP servers popping up, like, for instance, the GitHub server, where you can then say, oh, actually, I need I want to use this library and I don't have the docs, so fetch the LLM.txt from this GitHub repo, and it will go just using the MCP tool, right? So basically, as a dev, and I mean, you've used your share of CLI tools from the cloud provider and from all kinds of other infrastructure providers. There's a lot to learn and remember, right? So like all the API with all the individual commands and all the other stuff. And no one wants to remember this kind of stuff because that's not really valuable knowledge, right? So the same as you don't want to go into some crappy AWS UI and click together some services or something like that, right? Why shouldn't I be able to do this in the context of my code, where actually there's a much richer understanding of what do I want to deploy, why and where do I want to deploy it, what are like, what's my infrastructure setup in terms of like test staging, how many test runners do I need to do load testing on this, which is all in the environment configuration of my project anyway. If I connect this to the dev MCP servers that wrap the infrastructure APIs, then I can basically actually make much better decisions than if I go in isolation to these APIs or CLIs and need to reproduce through the human mind all the stuff.
You're more likely to miss something if you go in and do it manually.
Exactly, right? And then you can just tell it and say, hey, like for instance with Cloud Code or so, I just connect the MCP servers and say basically just in my interaction, and I need to spin up a test database for this, or can you write an integration test? Or for instance, I had recently one where I basically said, okay, we need to build this application, but I want you to test run all the queries that we built in this application against the real test database. So while it was generating the code, it at the same time took the queries that were part of the server, basically, or the service, and test ran it against the test database so that it validated that the queries were all correct that it generated. So it's also kind of a self-correction, self-evaluation part that you give the LLM, the code-generating LLM as well, not just linter and compiler like you have for code, but you can also do this on the infrastructure level for your databases, for your cloud APIs.
So where do you do it? Do you mostly do it in the infrastructure layers, or to help you create? And presumably this is dev time only.
So creation. These are dev time and perhaps deployment and DevOps and management time as well. So those are mostly dev time ones. We also have like the whole data MCP for agents and so on, which is kind of yet another topic as such, right? But I found this really interesting because, bringing all these things together basically for a dev is almost like you have this really like a toolbox basically, right? So where in the past, all these infrastructure services were kind of in silos, in isolation, right? So they didn't really work together. And even in a service like AWS or so, you still see that they're kind of siloed, and everything is kind of its own universe in a way, right?
Yeah.
So, but in your assistant, basically all the things come together as tools, basically.
Yeah.
And then the assistant actually creates this almost like federation layer across them, if you think about it, right? So and it takes the context of your code and your project into account, plus the instructions and the conversations that you have.
Yeah.
And so it has a much richer interactions, and it can cross things, right? For instance, it could take information from, let's say, your CI/CD run and generate new integration tests from it, or it can basically take information from your cloud database and use this to spin up a new container somewhere in an environment to do something, right? So it basically can also cross systems, basically, without you having to copy over stuff from
so long as, because it's agentic and it's kind of like making
and the
decisions
context
based
lives
on
in your AI IDE, basically, right? So it's not that you have to move to somewhere, but it's like in super rich context that's in as part of your.
And without it, it's that frustration of, I'm going to have an interaction with an LLM. It says something, but it can't do it itself. It tells me the steps that I need to do.
Exactly, and then please go ahead and copy paste, and then you become the junior dev who copies and pastes stuff to a form in, I don't know, in Cloud Run or in EC2 or something.
And then there's an error, so I have to copy paste the error.
Exactly. Why shouldn't it do it itself? Right? And then you can also start to, initially it might be manually interactive in the conversation, but then you can also tell Cloud Code whatever we just did there, turn it into a script or a CI/CD pipeline or something like that, right? And then it basically migrates something that you manually jointly developed into basically running code, into automation.
Let's talk about security. Actually, my previous job was Sneak. I've lived security for 6 years and continue to do so, of course. But
awesome.
as my role, I've lived security for 6 years, and now I do it as because I want to, because I enjoy it. Let's talk about security of MCP servers. Actually, you mentioned the GitHub MCP server just recently. There was a very interesting, I think, who was it?
2 weeks ago, last week, it was like an interesting
did you see
injection attack?
Yeah, that's right. That's right. It needed a bit of a setup in the sense. Well, it didn't need that much of a setup.
Not much, actually.
No, a user has an MCP server available, a GitHub MCP server available to the official one. Yeah, the official one. They have a private and a public repo. They ask something of the public repo. Maybe take a look at my issues and fix as many issues as you can, or solve as many issues as you can. Something that actually is not. It's a use case. It's a common use case of a GitHub MCP server. But if a malicious user adds an issue to the public repo, asking, something malicious, I want to grab as much information, private information about whatever. It can be as blatant as it wants to be. Then that MCP server will go, actually, I do have access to this user's other private repos. I'll grab that. And as a result of trying to fix or solve, it actually creates a pull request back on that public repo with that private information from the private repo and starts.
In the example, they just added a README with all the private information.
Exactly. Right? Yes, that was the example, wasn't it? Adds the README, and it's information leak from a private repo.
Yeah.
How do we? And it's really the authorization. Circumventing that authorization that a user does. That user have authorization to access that data?
The user has authorization for both, right? So, and basically they delegate this authorization to the MCP server.
Yes.
So the MCP server acts in the user's stead, but the MCP server itself is not problematic because it just basically is API access, right? So like we have API access today. The problematic thing is just that the LLM can't discern from what is data to process and instructions.
So basically, the data and control plane are merged.
Exactly. And that's one of the big challenges that we need to solve in AI systems anyway.
Yes.
So not just in MCP and coding assistance, but it's a general problem.
Yeah.
That currently data and instructions are not separate.
Yeah.
So I hope that the model providers will start tagging actually the different things, so that basically instructions that are coming from the user and are validated and verified are tagged as instructions, and the other things are tagged as processing data.
Yeah.
And then the LLM will treat, or that's actually the ideal, would treat the instructions as instructions and the rest just as processing.
Yeah.
There's a number of approaches that different people have proposed where you can do this today already, where you have basically almost like an hierarchy of LLMs that process stuff. So where you basically say, okay, the lowest level processing LLMs, they see the data and they get the instruction, but what they return is not plain text to the upper level LLMs, which could be interpreted as instructions again, but they just basically generate tokens or file names or something like that, where basically they just hand pointers, and then the content of this is actually not processed in the LLM, but just, for instance, shown on the UI. So it's basically something that goes on a side channel, not through the LLM, but on a side channel, and then the UI will just show it like you would do in a normal UI. So that's one way of how you can circumvent things like that. Or where you say, okay, the lower level LLM does just data processing, but it's not allowed to basically exit its scope, basically where you scope the LLM, that it can only do something, for instance, in the public project and can't access this other information. So it's about like a mix of, so the root problem is data and instructions are on the same level, which is kind of, we had the separation of this in computers since architecture, basically, right? So that's one challenge. And the other one is kind of how are things scoped and who has access to what, right? So you need some kind of like sandboxing almost for those, right? So, and that's really not just related to MCP, even if you use other tools.
It's an LLM.
If you would use, let's say, API calls, you could do exactly the same, right? So it's more like an LLM problem than an MCP problem. It just makes it much easier with MCP, because MCP now opens up all these services and like Lego blocks, you can combine them. And I mean, the first rule would, of course, only use trusted MCP servers.
This was one of the things I was going to say, because it kind of like reminds me a little bit of almost like open source components, right? You still need to do your due diligence. You need to recognize who they're coming from. And it's like, otherwise we're just going to start adding potentially dangerous things into our code base that can actually, not just dangerous things, they can perform actions, right? And they can describe.
So it's software supply chain again.
It is. So it's exactly that. It's supply chain.
Look at Snook also entails, right? So software supply chain attacks and things like that. And I think this whole area is still growing up, right? And that's why I would also say you should also basically limit and sandbox where you use this kind of stuff, right? So for instance, in really mission critical areas, I would try to avoid using all the bleeding edge things, but only use like things where you as human actually copy and paste stuff from A to B, which is safer than basically running it as automation. And I would do it more in the exploration phase, where you basically try out new things and so on harmless projects where you work, where everything is an open source project. So for instance, what I do when I use these kind of GitHub integrations, I only give it access to my open source repos. I never give it access to my private repos because I don't want to accidentally leak something. Or sometimes I just create another GitHub user that has only access to the public repos if it does not work with the tokens. Right? So, and that's where for experimentation you want to basically be in a space that's really like a open sandbox, right?
And I think that's the core. What you're doing is you're putting the security, the authorization in the hands of a deterministic model. Something that has strong authorization and authentication built in. You're not providing the data to the LLM and allowing the LLM to make that decision as to what is and what isn't reasonable to put out.
Or you separate the processing, right? So the processing happens in kind of sandbox environments, and then the results of that are taken basically really just as data, and would basically. Imagine you would say, okay, let's process these issues. It would not go through the LLM, but it would just basically do an create issue call with the content that was generated, but the content would never be looked at by the LLM, but it would be just passed into the API call as something, so it would never be able to use this as an instruction, basically, right? So, and that's where the sandboxing of these individual parts comes in. But it's an interesting space, and I think the security, people say there's the S in MCP, right?
Is that the new version of the S in IoT stands for security?
And I mean, it's also really, I love that people try to find these kind of loopholes and injection attacks and so on, because that helps making stuff better. But that's also a little bit of an arms race, right? So
absolutely.
So it's also fun to watch in a way. And but with all new technologies, you have these things, and we need to sort out the kinks of new.
Sounds good. Let's give some practical advice to developers out
Yep.
there in terms of which MCP servers they should be considering. What's on your list of things that you use maybe at Neo4j, or that you've seen people use that you think, oh wow, that looks pretty cool. That's actually really helped.
So for me, the extended thinking MCP server from Anthropic is actually quite useful.
Yeah.
Then Anthropic added an MCP server that is like a memory MCP server, which is actually quite cool.
Yeah.
Which basically can take information from you, store it in. Actually, interestingly, they picked a knowledge graph as a representation.
Mm-hmm.
So we built a Neo version of that, which actually can start accumulating information from conversations into an structured data structure, and which you could even share across a team. So imagine you as a team are working on something, and for instance, you're working on project specs or so, right? So then the information from the conversation could be extracted and added to this joint knowledge base in a way. So that's something really interesting. The other ones that I've been using is mostly the stock ones like Cloudflare and GitHub and Slack a little bit, Notion as well. Actually, I learned last week about Pipedream, which is like an integrator for MCP servers. They have like 2,700 or so MCP servers.
Yeah.
Of course, they have many other registries. And I saw last week as well that Mastra AI, the agent JavaScript tool, they have actually an MCP registry.
Oh, really?
It's insane. But Pipedream I found interesting because they basically allow you as application builder to quickly integrate a bunch of MCP servers that they actually validate and partially also self-host as well.
Yeah.
So you have like a curated version of like, you have like the Notions, the Slacks, the Salesforces and so on as MCP servers.
Yeah.
And that's something that might be actually quite
cool.
nice if you build agentic integrations and stuff.
Yeah.
But what I actually would recommend, build your own.
Yeah.
Right? So, take your own, whatever you're working on, your own APIs or your own infrastructure, and just get a much better understanding of how MCP works by building your own MCP server, like adding a bunch of tools and prompts and resources. So you have a much better first-hand understanding what's actually happening behind the scenes. Because I think that's one of the dangers if everything is like a black box and magic, then either you don't trust it at all because it's black box, or you blindly trust it, and neither side is a good place to be, right? I always said in the past as well, if you make conscious decisions, informed decisions, by having learned before you make the decision, then it's much better decisions, right? So, and actually, building MCP servers is not hard today. You can use fast MCP or so, and it takes, I don't know, an hour or two to do one. You can even vibe code it if you want to, but it's 200 lines of code or so, and that's actually something that gives you a much better understanding of MCP.
And I think also there's a ton of validation style things as well that we can kind of like add in. I know Sneak, for example, create an MCP server, so you can just kind of say any security issues in my code, it'll go off, run Sneak code, I think, and it will provide you information based on that. Another interesting one that I've looked at is Context 7, which I've heard a ton of people talk about, whereby it actually gives you a more accurate code generation. So if you're I don't know, if I'm coding against a certain version of something, rather than just try and get huge amounts of information and try and base the code suggestions to me on every version that I could be using, it recognizes, I need to go to this version of the docs or this version of the API, and I'll only provide you suggestions from those, so it can kind of make that more accurate in terms of the suggestions. There's a ton of them out there.
I heard about Ref. A friend of mine recommended Ref to me.
Okay.
Ref is also an MCP server or an service that provides LLM optimized documentation for different tools and libraries, basically. So it basically like an LLM TXT for each of these kind of frameworks. Like they have a few hundred frameworks that they support. That's also an interesting one as such. What could be actually really interesting from the security angle is if you think about proxy MCP servers, right? So one MCP server that proxies another one and actually does filtering of the content that goes through. That could be really interesting.
That's interesting,
right? So where you basically add a layer of security on the ingoing and outgoing data, where you can basically validate certain things with a third-party service.
Gates and guards to
exactly. So that will be an interesting one, and I think we will see more and more that companies will establish these MCP kind of gateways almost, where they have like, these are the allowed MCP servers in our organization. We add these kind of security authorization controls and also like filter and validation. What can we let go out into the world of the MCP tools and whatnot.
Kind of it feels like almost like what Lakira are doing from a prompt point of view and having guards on the input and output
exactly.
to and from an LLM,
exactly.
but to MCPs or something like that.
It kind of feels a lot like in the spirits of when GraphQL came out in 2016.
Yeah.
So because there's now also like the spec, the working groups, like everyone is jumping on it. There's lots of energy and lots of enthusiasm as well. And it's also open source. So I feel very much reminded of back then when we were at Facebook and the GraphQL working group and working with them. And so that was actually a good time. And I feel like same energy and also kind of same approach, like a grassroots movement more, right? So yes, there's a proposal from Anthropic, but then it grows through all the people contributing, right? And then the big players were actually more or less forced to come on board by the developer groundswell, which is amazing, right? So how often do you have this that like Google, Microsoft, OpenAI, and the others are actually forced by developer adoption to join
to get in the game,
initiative. So it's like FOMO for the big ones. But it's usually the other way around. Right? So it's actually quite cool. Yeah,
awesome, Michael. I got a presentation to give in 5 minutes, right?
Exactly.
I got to run, Michael. Absolute pleasure.
So
Absolute pleasure to see you here again, and we should do this again. But thank you very much. And if you're interested in graph databases, particularly for I think the RAG style. Sounds super interesting, and I think very, very valuable.
Feel free to reach out. Happy to chat and let me know if you need any more. So, and otherwise we go and see Simon.
Let's go see my talk.
So I go see you.
I'll go sit down in the front row and see how it goes. Yeah. All right. Thanks very much, and thanks all for listening. Tune into the next episode.
Take care.